All right, let's get excited about doing a proof with all the information we just learned. So in this example, we're given circle P. That's the only thing they gave us. So that goes in our first statement, circle P. And how do we know that circle P exists? We know because it was given to us. So it's kind of nice when they give you information, you just write it in and there you go. All right, now we're going to prove that side AB is congruent to CD. So you can see that that's already written down here as the last step because that's what you have to prove. Now we've got some gaps to fill in and they didn't spell anything else out for us. So we have to look at our figure and see what we can deduce or deduct about this figure. Well, the fact that we have a circle actually tells us a lot. And here's the center of our circle right there. And what you notice is we've got from the center of the circle to the edge of the circle in 4 spots, we've got 4 radii. And the radii of all radii within a circle are congruent. So we can go ahead and mark all 4 of these segments as congruent. All right. Now, if we're focusing on just the 2 triangles, our goal is to, if we can say that these 2 triangles are congruent, then we can jump to that statement, and I'll show you how that works in the end. So we've got 2 congruent sides right now. So we either need to get a third side congruent, or if we can get an angle congruent, then we can use one of our, side, angle, side, blah, 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 one of those. So I'm going to get to that in a minute. First, let's go ahead and write in what we just figured out. We know that we're going to put this all in the same thing. That side CP is congruent to side DP, which is also congruent to side AP, which is also congruent to side BP. And how did we know all of those segments would be congruent? Because we know that all radii are congruent. Okay, so what else do we know? Well, if you kind of look at these longer segments, you've got this line intersecting this line, and anytime 2 lines intersect, you get vertical angles. So the vertical angles that we care to focus on here are the pair that are within the triangles. So you've got this angle and this angle that are vertical angles, and vertical angles are congruent to each other. So we're going to go ahead and state that those 2 angles are congruent. So we're going to say angle CPD is congruent to angle APB. And what was the reason? Well, we know that vertical angles are congruent. I'm doing a little bit of abbreviating. I don't have a lot of space. All right, so what we just figured out is we have a side, and an included angle. So that's going to be side, angle, side. And over here on the left, we've proven the sides and the angles are congruent. So our next step is going to say that those are 2 congruent triangles. So triangle CPD is congruent to triangle APB. And how did we know that? That's from side, angle, side. All right, so now that we have 2 congruent triangles, you've got 6 statements you could make. You could say that any pair of corresponding sides are congruent, or any pair of corresponding angles are congruent. So we know that AB is congruent to CD because corresponding parts of congruent triangles, we have congruent triangles right now from step 4, are congruent. So CPCTC is that final step, and that's all you have to write. You don't have to write it out, just abbreviate it. Done. We've proven those 2 segments or those 2 sides as congruent.